Bismillahirrahmanirrahim. In the name of Allah, the most beneficent and the most merciful. Dear students, welcome you all in Pakistan International School Taif Virtual Learning System. Today is our third video lecture, and this lecture is for grade second year students, boys and girls. I'm Mrs. Rosia Imran, your mathematics teacher. We already done exercise 1.1. Today we will start a new exercise, that is exercise 1.2. Composition of function. Before going to start exercise, we should know what is composition of functions. So if we have two functions, let f and g. Let f be a function from small x. Look, f be a function from x to y, and g be a function from y to z. Here we have two functions. Look, f be a function from x to y, so y is equal to f of x, and g be a function from y to z, so z will be equal to g into f of x. So the composition of f and g is a function denoted by g of f. The composition of f and g is a function denoted by g of f from x to z, and is defined by g of x is equal to g into f of x and equal to g f of x, such that small x belong to capital X, and small x are the elements of this set x. So this is composition of a function. If you look at the example, in example you have given f of x is 2x plus 1 and g of x is x square minus 1. If you want to find f of gx, so means that in the function f of x, where you find x, you put this g of x value. So f into g of x, look, f is the function. Inside the function, inside x, what you will write? The value of gx, x square minus 1. So in f of x function, you have 2x plus 1. So in place of x, you have to put this gx value, x square minus 1 plus 1. When you open the bracket, 2x square minus 2 plus 1. So you will get 2x square minus 1. So in this way, you have to find the given functions. This is called composition of a function. Now here, if you look at this exercise, in this exercise 1.2, you have given that f of x is 2x plus 1 and g of x is 3 over x minus 1, where x is not equal to 1. If it is equal to 1, so this function will be undefined. So therefore, x condition is given, x is not equal to 1. What you are going to find? You are going to find f of gx. Means that in place of f of x, in place of x, you have to put gx, and where in this function f of x, where you find x, in this place x, you put the value of g of x. So look, f of gx, f into, in place of x, gx is equal to f, or in place of gx, you have to put this function 3x minus 1, and the function f of x is 2x plus 1. So in place of x, you have to put 3 over x minus 1 and plus 1 as it is. Now you open the bracket, 6 over x minus 1 plus 1. Now take the LCM, so you get x minus 1, 6 plus x minus 1. So that will be equal to x plus 5, x minus 1. So the real valued function f and g is given. So you have given the condition in first a part. F of gx means that in this function in f of x you have to put g of x. Where you find x, in place of x you put the value of gx. So similarly in second, in b part, you have given g of x. G of x means that in function gx, this is function gx, where you find x, in place of x you put the value of f of x. So g of x, you have to write it like this, g into f of x. So g f of x is given 2x plus 1 equal to, in the function gx, where you find x, in place of x you have to put this value 2x plus 1. So 3 over x minus 1, so you put 3 over 2x plus 1 minus 1. So minus 1 plus 1 cancel and you get 3 over 2x. Now come to the third part. In third part, f of f means that in the function f of x, you have to put f of x. Where you find x in the function, there you put the value of f of x. F of x, you write it f into f of x, f into the function f of x is 2x plus 1. So now where you find this x, in this place of x you have to put 2x plus 1. So 2 into 2x plus 1 multiply with 2, so it will be 4x plus 2 plus 1 and 4x plus 3. So this is the third part. Now come to the fourth part. In fourth part you have given g of gx. So means that in the function g you have to put the value of gx. So g into g of x, and g of x is 3 over x minus 1. So where you find this x, in place of x you put 3 over x minus 1. So you put 3 over x minus 1 minus 1 is equal to 3 divided by, you take LCM, x minus 1, 3 minus x plus 1. When you take the LCM, x minus 1 is in the denominator. When you shift it in the numerator, so it will be 3 into x minus 1 and 3 plus 1, 4 minus x. So this is the required answer. In the same way, you have to find these four function f of g and g of f and g of g for the second part, for this part. The same process you will repeat for the second part. You have four parts, and for each part you have to repeat these four steps, which one is f of gx, g of fx, f of fx, and g of gx. So f of function is given, f of x is under root x plus 1 and g of x is 1 over x square. When you have given f of gx, so means that in the function f of x, where you find x, you put the value of gx. So f of gx, you write it like this, f into gx, and gx function is 1 over x square. So in the function f of x, where you find x, you put the value of gx 1 over x square. So 1 over x square plus 1, take the LCM, it will be x square, 1 plus x square. So this is the, when you apply the square root on the denominator, so it will be x. So under root 1 plus x square over x. So this is the first A part for second part. B part for second part is g of x, means that in the function g of x, in this function, where you find x, you put the value of f of x. So g of f of x is g under root x plus 1. So where you find x in the function g of x, you put this value. So 1 over under root x plus 1, square root and square cancel, so you get 1 over x plus 1. So similarly, you will do f of fx, means that in the given function f of x, where you find x, you put under root x plus 1, like this. So under root x plus 1, so it will be the answer. You can't simplify it more, so you will write it as it is. Next is g of gx, means that in the function gx, where you find x, you have to put the value of gx, which is 1 over under root x square. So 1 over 1 under root x square whole square, so you get 1 over 1 over 4. If something is in the denominator it will come in the numerator, so you get x power 4. So these four parts A, B, C, D you solve for the second. So similarly you have third part and fourth part, you will solve it just like first and second. So you do it by yourself. Now come to the next question. Before going to start next question, first you know that what is inverse function. Inverse function, let f be a 1 1 function from x onto y, means that 1 1 function for each domain you have a separate range and domain both are not repeated. So the inverse function of f denoted by f inverse f power minus 1 is a function from y onto x, means that if you have a function from x to y, so it's x to y you have a function f, so its inverse will be f inverse, which will be from y to x, and that will be for 1 1 function like this. Look, if f is a function from x to y, so x is equal to y is equal to f of x. So f inverse will be the inverse function from y to x. So such type of function in this domain of f will be domain, this is domain of f and this is range of f. So domain of f will be equal to the range of f. Look, when you have the direct function, so this one is domain and this one is range, and in inverse function this one is domain and this one is range, means that in inverse function domain of f domain of f inverse will be equal to range of f, and range of f inverse will be equal to domain of f. Now come to the exercise question number 2. You have given that for the real valued function f defined below, f inverse x, you have to find f inverse x. Y is equal to f of x minus 2x plus 8. This is given. This is the first part of question number 2. And you have to find for this f inverse x. So how can you find f inverse x? Y is the image of x under f. You know that y is the image or range and x is the domain. So y is the image of x under f. So you have to write f of y is equal to f of x. So y is equal to minus 2x plus 8. So from this you find the value of x. So here minus 2x, when you shifted at other side it will be positive 2x, and y is positive when shifted at other side it will be negative. 2 multiply with x shifted at other side it will be divided. So f inverse y is equal to 8 minus y divided by 2. To find f inverse x, this you are going to find, this is the requirement of the a part. F inverse x you are going to find. So replace y by x. Where you find y, here you write x. So f inverse x will be equal to 8 minus x. Where you find y, you replace x. So 8 minus x over 2. So second part, B part for this is f inverse minus 1. Where you find x, you put minus 1. So 8 minus into minus 1. So 8 plus 1 divided by 2, 9 over 2. Now you have to verify also that f into f inverse x is equal to f inverse into f of x, which is equal to x, means that its answer is equal to x. You have to prove this also. So first we find this left hand side and then we find its right hand side and prove that both give answer x. So left hand side is f into f inverse x. So f into f inverse is equal to what? f inverse x is equal to 8 minus x over 2. So we put that value in f of x function. Function is what? Function is minus 2. F of x is equal to what? 8 minus x over 2 minus 2. Where you find x, there you put the value of f inverse x at minus x over 2 plus 8. So 2 cancel with each other. So minus 8 plus x plus 8 plus 8 and minus 8 cancel. So you get x. Now you have to take the right hand side f inverse into f of x. This is the first result, left hand side. Now right hand side f inverse into f of x. So f inverse, and you have to write the function f of x, the original function, which is equal to minus 2x plus 8. So where you find x in this function, you put the value of in f inverse. In f inverse function, f inverse function is what? 8 minus x over 2. Where you find x, in place of x you put minus 2x plus 8. So 8 minus 2x plus 8 divided by 2. 8 plus 2x minus 8 plus 8 cancel, 2 and 2 cancel, so you get x. So right hand side is also equal to x. So from 1 and 2 we get that f into f inverse x is equal to f inverse x into f of x, x. So means that in question number 2, what you have to do, first the given function, you have to find the value of x from that function. You know that f of x is equal to y. So you suppose that let, if you have a function from x to y, so y is equal to f of x, you know that. So let you suppose that this function, in place of f of x, what you write? Y is equal to minus 2x plus 8. From this you find the value of x. When you find the value of x, so that will be x is equal to what? F inverse y, because the image of the next function, so f inverse y, so 8 minus y over 2. X is equal to, y is equal to f of x, and x is equal to f inverse y. So to find f inverse x, replace y by x. Where you find y, you put x. After that you have to find this b f inverse minus 1. When you find, then you verify this function. First you solve for the left hand side and then you solve for the right hand side. Now come to the second part. In second part, you have given f of x is equal to 3x cube plus 7. 3x cube plus 7. So first of all, you suppose that let y is equal to f of x, this. So in place of f of x, what you put? So that y is the image of x under f. Therefore, in place of y, in place of f of x, you write y. So y is equal to 3x cube plus 7. So from this, you find the value of x. To find the value of x, you have to shift this 7, so it will be y minus 7. 3x cube, 3 multiply here, shifted at other side, divide. To find the value of x, taking cube root on both sides, so x is equal to y minus 7 divided by 3 whole cube root. In the second, f inverse y minus 7 over 3 cube root 1 over 3. So what we done? We find the value of x, y minus 7 over 3 whole cube root 1 over 3. So this x we replace, you know that f inverse y, I already told you that in composition of function, when you have a function from x to y, that will be f, and when f inverse, that will be from y to x. So fx will be equal to f inverse y. So that is equal to y minus 7 over 3, 1 over 3, just like the previous part. In part 1, you have to replace, where you find y, you have to replace it with x. So f inverse x is equal to 3 minus 7 over 3, 1 over 3. And the second part is that you have to find f inverse minus 1. So where you have x, you put there minus 1. F inverse minus 1. So minus 1 in place of x, minus 7 over 3. So minus 8 over 3 cube root. This is the B part. Now you have to verify this. This is given in the question, that third step is to verify this. F into f inverse x and f inverse into f of x, which is equal to x. This answer should come from the left hand side and from the right hand side. F into f inverse x, when we take the left hand side first, so means that f into f inverse function, you write it here. This is f inverse function. In the original function, in function f of x, which is given in the question, minus uh, given in the question, that is, in that you have to put the value of this one value, x minus 7 over 3, 1 over 3, in the original function. The original function is what? 3x cubed plus 7, which is given in your book, f of x. So in place of f of x, you have to write f into f inverse x value you put here. So now original function is 3x cubed plus 7. So in place of x, you put this value, x minus 7 over 3, 1 over 3 whole cube. So cube root and cube cancel with each other, and you 3 cancel with 3. So you get x minus 7 plus 7, minus 7 plus 7 cancel, so x. So the left hand side answer is x. Now the right hand side, f inverse into f of x, means that in the inverse function, in this function, in the inverse function, this one function, in inverse function, where you find x, you put the value of f of x. So f inverse into f of x. So f inverse, value of f of x is 3x cubed plus 7. So in inverse function is x minus 7 over 3. So in place of x, you put this value, 3x cubed plus 7 minus 7 over 3. So minus 7 plus 7 cancel, 3 cancel with 3, cube cancel with cube root. So you get x. So means that left hand side from 1 and 2, you say that f into f inverse x is equal to f inverse into f of x is equal to x. You prove this. Similarly, you have third part. In third part, you have given minus x plus 9 whole cube. So this f of x you suppose equal to y, just like we done it in the first part and second part. Y is equal to f of x, which is equal to minus x plus 9 whole cube. So that y is the image of x under f. So y is equal to minus x plus 9. Now from this equation, you have to find the value of x. How can you find it? First, you remove this cube. To remove the cube, we taking cube root on both sides. So y 1 over 3, and this cube will cancel with cube root. So we get minus x plus 9. Here negative x shifted at other side, it will be positive x, and y 1 over 3 positive and shifted at this side negative. So to find f inverse x, this is f inverse y. F inverse y you find. To find f inverse x, we replace y with x. Where we find y in this equation, we replace it with x. So f inverse x is equal to 9 minus x 1 over 3. Now f inverse minus 1 you have to find. Where you find x, you put minus 1. So you get 9 minus into minus 1 over 3. To verify that, this function just like we done it in the first part and second part, f into f inverse x. So f we write, and in place of f inverse x we put its value. We already find it, f inverse x, that is equal to 9 minus x1 over 3. So in place of f inverse x, we put 9 minus x1 over 3. Now this function f is what? Function f is minus x plus 9 whole cube. So minus sign, in place of x, we put this value, and plus 9 whole cube. Now open the bracket, minus 9 minus minus plus x 1 over 3 plus 9 and minus 9 cancel with each other, x power 1 over 3, 3 and 3 cancel with each other, and we get x. This is the left hand side. Now we have to solve the right hand side, f inverse into f of x. Means that in f inverse, where we find f inverse, we already find it, 9 minus x 1 over 3. Where we find x, we put the value of f of x. So f inverse f of x is what? Minus x plus 9 whole cube. So in the inverse function, in one function is 9 minus x1 over 3. So 9 as it is, minus, in place of x, minus x plus 9 whole cube power 1 over 3. 3, 3 cancel. Now we open the bracket, 9 minus into minus x plus 9. So 9 minus minus plus x, and plus minus minus 9, which is equal to x. Minus 9 and plus 9 cancel. So f inverse f of x is also equal to x. So from 1 and 2, we have to prove that this is equal to x. In the same way, you have to do the fourth part by yourself. Now come to the next question. Question number 3. Question number 3 is that without finding the inverse, state the domain and range of f inverse. Means that you have, in question number 2, we find first inverse and after that we solve it. But in this case, they say that no need to find the inverse. Without finding inverse, you have to write the domain and range of f inverse x. Look, f of x is under root x plus 2. So let y is equal to f of x. You know that equal to y. When we do composition in this, you saw that x is equal to x and y to set, and f is a function from x to y. So y is equal to f of x. So y will be real if x plus 2 is greater than equal to 0. How? Look, if it is less than, let's suppose if it is less than 0, so you know that it will be under root negative value, and under root negative value are the imaginary number. Under root minus 1 are imaginary number. So y will be real if x plus 2 is greater than equal to 0. So if it is, so this function x plus 2 is greater than equal to 0. Now this 2 is positive here. When shifted at other side, it will be minus 2. So domain is started from which number? From minus 2. Look, x is greater than equal to minus 2. And domain of f will be started from minus 2, means that the minimum value will be minus 2. And less, greater than, x is greater than equal to minus 2, means that minus 2, minus 1, 0, 1, 2, 3, up to so on. So domain of f will be minus 2 to positive infinity. Look, this is the square bracket which show that minus 2 is included in the domain, and this is parenthesis or open bracket. So means that up to plus infinity, not exactly positive infinity, up to positive infinity, any number up to the positive side. And range will be what? Look, When you put minus 2 here in the given function, you know that range, how can we find it? If the domain we know, domain we find from the function x plus 2 greater than equal to 0, 2 shifted on other side minus 2, so domain of f is x is greater than equal to 2, so minus 2 to positive infinity. If we put negative 2 in this, so it will be minus 2 plus 2, so we get 0 under root, so 0 under root is equal to 0, so means that range is started from 0 to positive infinity. By definition of inverse function, if we check the definition of the inverse function, the domain of f inverse is equal to the range of f, and the range of f inverse is equal to the domain of f. So domain of f inverse is equal to range of f. Range of f is this. So range of f inverse is equal to domain of f. So without finding the inverse, we state its domain and range. So by definition, for inverse function, domain of f inverse is equal to range of f, and range of f inverse is equal to domain of f. Like this, we have to find the domain and range for the inverse function. Now come to the second part. In second part, you have given f of x is equal to 1 over x plus 3, where x is not equal to minus 3. So again, we suppose that f of x is equal to y. So y is equal to 1 over x plus 3. The function is not defined at x is equal to minus 3. Why it is not defined to um, x is equal to minus 3? Because if it is minus 3, let's suppose x is equal to minus 3. So minus 3 plus 3, it will be 0. So 1 over 0 is infinite condition. You can check that 1 over 0 is equal to, or any number divided by 0 is equal to, it will be undefined condition. So therefore, the function is not defined for x is equal to minus 3. So domain of f will be all real number except, means that minus 3. This minus 3 will not included in the domain. All real numbers will be included in the domain. So if minus 3 you put in this function, minus 3 plus 3, it will be 0. So means that the range will be a real number, all real number except 0. So we put this domain value in the given function and find that range will be equal to 0. So by definition of function for inverse, we have domain of f inverse is equal to range of f, and range of f inverse is equal to domain of f. So the domain of f inverse will be real number minus 0 except 0, all real number except 0, and range of f inverse will be domain of f, all real numbers except minus 3. So in this way, you have to solve the third part and fourth part. In the same way, you have to find the third and fourth part. I hope you will understand this exercise. Inshallah, next exercise we will start in the next lecture. Take care. Allah Hafiz.